Continuing on, this should be the last video. It should be a little bit shorter than the other two. What is the most number of colors needed to color this map? This map only needs 3 colors. The explanation is that this inside color can be the same as these 3 little loops on the outside. This section right here can be the same as what's outside, because remember, you have to color the outside like the ocean. And then this region right here would be the 3rd color. So the most you actually need is 3 colors. Remember, in map coloring, colors cannot share a side. They can share a vertex here like these 2 sections do, but they cannot share a side. The most number of colors needed for this map, this one, it should be pretty simple. This is 2, because every section can alternate colors with the exact same 2 colors because it's the bullseye appearance. And then, true or false, a map can be created that requires the use of 5 colors. That means you have to have 5 colors in order to adhere to those rules I just described, where no 2 colors can share a border. You have to have 5. That's what this question is saying. The answer here is false, because you cannot create a map that needs more than 4 colors. 4 is the most you will ever need. Now looking at probability, a marketing class polled 150 people at the Westgate Mall to determine how many read the Amarillo Globe and how many read the Canyon News. They found out that 126 read the Amarillo Globe, 31 read both, 10 read neither. Select the appropriate Venn diagram. Well, the key here is 31 read both and 10 read neither. Well, 31 needs to be in the middle and 10 needs to be on the outside. So that's true for these 2, and it's not true for these 2 here. C and D can be eliminated. The other key is 126 read the Amarillo Globe. So that's 126 including the both. So the globe here needs to add up to 126. That is A. Then we need to use that Venn diagram to answer some probability questions. What's the probability the person only reads the Canyon News? Well, there's 150 people total, and 14 of those only read the Canyon News. We're going to make sure we simplify this. That's a 7 over 75. The bottom here, what's the probability that someone reads the Amarillo Globe or the Canyon News? Well, this one here is Amarillo Globe or the Canyon News. This is not both. So I believe this is 109 divided by 150. Use this image for the following questions. This image is actually a little bit off. This one right here, if you notice 2 boys, the option of the middle 2 children as being boys is missing. So this should say girl, boy, boy, girl here on the bottom, and there should be 6 options here in the middle. So that being said, what's the total number of outcomes? The other nice way to figure this out is this is called binomial probability, and each event has 2 possible outcomes, which means this is 2 to the 4th power, which equals 16 possible outcomes. What's the probability that a family of 4 children will have 2 boys and 2 girls? Well, remember, this is missing 1, and 2 boys, 2 girls should have 6 possibilities. So that's 6 out of 16, which is 3 out of 8. What's the probability of having no boys in a family of 4 children? Well, that means all 4 girls, 0 boys. That's going to happen once, theoretically, out of 16 times. And then you have the question, what's the probability that the oldest is a boy? Well, you can go up here and count every time the B comes first. Or you can just think, well, the oldest child is the first child, and what's the probability that you have a boy for your first child? Well, that's 50%, or 1 out of 2 possibilities. The oldest is a boy is a 50% chance. Now we're going to describe some scatter plots. This one here, if you say anything other than no correlation, you're saying too much. There's no correlation here. You cannot use this to predict anything. There's no direction, there's no form, there's no shape, there's nothing, there's no correlation. To describe this scatter plot, well, we can see it's going in a positive direction. And since it's continuously going in a positive direction, we say that it's a linear form, but it has moderate strength. I could potentially predict, but I wouldn't be necessarily overly confident of my prediction. But I can see it's going in a positive and linear direction. This graph here, we can see it's going in a negative direction the entire way, which means it's also linear. And based on how close those points are to one another, I would say that this is very strong. Pardon the bell. Here we have some weighted averages. You might need to know a little bit about baseball, but if you read here, we have X number of singles, 35 doubles, 2 triples, 22 home runs. Overall, we have 168 hits and 521 at-bats. Well, to figure out the number of singles, you take the total hits, which is 168, and then you subtract everything else. So 35 doubles, 2 triples, 22 home runs, and that's going to equal 109 singles. To find the average, the batting average, you take the number of hits, which is 168, divided by the number of at-bats, which is 521. And guys, if you put a decimal right here when you type it in the calculator, it will automatically convert it to decimal form in the calculator for you. Here we get 0.322 for the batting average. And then for the slugging percentage, or the slugging average, we have 1 times the number of triples, plus 2 times the number of doubles, plus 3 times the number of triples, plus 4 times the number of home runs, all divided by the number of at-bats. I'll make this a little bit smaller here so it all goes on one line. And then you put that into the calculator, and again, if you just put a decimal right there before the division sign, it should give you the decimal form. So 109 plus 2 times 35 plus 2 times 3 plus 4 times 22, all divided by 521. Okay, so that didn't give me, putting the decimal there didn't give me the answer I wanted. But maybe if you put the decimal after the 521. There you go. If you put the decimal after the 521, it will convert it. And your answer is 0.524. And then estimating large numbers. This is something we went over early on in the year. There were an estimated 2.5 million spectators at the Macy's Thanksgiving Day Parade, November 25th, 2004. How could they have determined this amount? They could have estimated the area of space for spectators to stand, then divided by 2.5 square feet per person. They could have counted the number of people walking in the parade. Well, this doesn't make any sense because we want spectators, not participants. So the same reasoning applies to this one. Count the number of floats. Those are participants, not spectators. And then find the population of New York and multiply it by a small percentage. In theory, you could multiply by a small percentage, but how do we know which percentage to multiply by? So, and also not all the Macy's Thanksgiving Day Parade spectators are from New York. So we can't just take the population of New York. So we have to have some way of dividing it up by per person, which is the first answer. Guys, that's the end of the second semester final exam review. Good luck on a test.